Hi, Doc Revis here with Watch Me Work It. Thermodynamic calculations of heat from a balanced equation. So watch me work it. Here's the problem. The enthalpy of combustion of ethanol is negative 1,367 kilojoules per mole, according to the balanced equation. How much heat is involved when 15.5 grams of ethanol is burned? So watch me work it here. First, we have to balance the equation. In this case, we need a 3 here. To balance this, we need a 2 here. Well, whatever means you do your balancing equations, just make sure they're balanced, and a 1 here. Also, we note that this is a negative 1367, so that means it's written on this side of the balanced equation. So there we have, that's our balanced equation. Now we can work the problem, and here we go. How many grams is involved when that ethanol? So we just take ethanol, 15.5 grams, and I'm just going to abbreviate ethanol as ETOH times bar here, and this is going to be grams to mole here, and that will get us to the moles, and then we will do moles to kilojoules, and we can do this because we have this in kilojoules per mole, which we don't normally write up here, in the balanced equation. So next we'll go back and just put our values in. The molar mass of ethanol goes here, 46 grams per every 1 mole, and the mole, this should be a mole, per kilojoule here for ethanol is 1 mole of ethanol per negative 1367, and if we punch this number through, we'll get a minus 461 kilojoules. And this is exothermic because it's negative. That means heat is released. This is a downhill process. The next one, how much heat is involved when 8.2 grams oxygen gas is used? So we'll do the same thing here, or a similar thing. 8.2 grams of O2 is what we are given, times bar gram per mole of oxygen. I'm going to write it in here so I can keep my eye on it. This is O2, and this was ethanol up here, and we get ethanol down here. Okay, so we get moles of O2 times moles of O2 to Kj, and this is in the balanced equation, therefore I can use it. And if I go back and put my values in, we know that this is going to be 32.00 grams per every 1 mole. And here, if we look at the balanced equation for oxygen, this is going to be a 3, and this is going to be a minus 367. And if we punch this through, we get a minus 116.76 by a calculator. But if we look at sig figs, we only need, what do we need? 2 sig figs. So this is going to be a minus 120 kilojoules per mole. Okay, let's work another problem. We have the enthalpy of combustion of acetylene is minus 1,301 kilojoules per mole, according to the balanced equation. And so here we want to know how much heat is involved when we have 15.5 grams of ethanol. Oops, not ethanol. That should be, let's change that right away, of acetylene. We're just going to keep it right there. Okay, we're not going to redo this one. Of acetylene is burned. So if we burn acetylene at 15.5 grams here, that's going to be 15.5 grams of acetylene. I'm just going to abbreviate it with AC there, times here, and this is going to be grams of acetylene to moles of acetylene, and then we're going to take moles of acetylene to kilojoules here of acetylene. But if we look at this, we have a problem because we don't have a balanced equation. So we're going to go back now and just go ahead and balance this equation then. 4 here, and we have a 2 here, and we have this value, so it's going to be right here. Okay, Now that works for us. So now we have grams of acetylene per mole of acetylene. This is 26.00 to every 1. Again, don't forget to balance your equations. Always, if you haven't, just go back and you balance it, and then you use dimensional analysis to solve the problem. So if we put in the values here, we see a 2 in front of the acetylene, and if we calculate these numbers, we would get a minus 388 kilojoules for this particular process. So that's how much heat is generated. Again, don't forget the balance equation and use coefficients from the balance equation appropriately. So now how much, and so this heat, by the way, is also exothermic because it's minus, it's released, it's downhill. How much heat is involved when 7.13 grams of carbon dioxide is generated? Okay, so in this case, we generated carbon dioxide. We already have a balanced equation. We already have our energy written in the balanced equation. So we start with 7.13 grams of CO2 times bar grams of CO2 to moles of CO2 times bar moles of CO2 to kilojoules. Okay, here. Okay, just kilojoules there. Let me clean that up just a little bit for you. Kilojoules. So we have that, and the molar mass of carbon dioxide is 44.00 to every 1. And here we go to the balance equation in front of carbon dioxide, and we see we have a 4, and this is a minus 1301. And if we calculate that through, we would get a minus 527 kilojoules. This is also exothermic and is energy released. Okay, let's do another one here. We have decomposition of ammonia, and it takes 92 kilojoules per mole according to the balance equation. Then we want to know how much heat does it take when 5.2 grams of ammonia reacts, or is actually reacts or decomposed. Let's just change that wording. Decomposed. Okay, reacts, decomposed. Same thing for us. So here we need to make sure we balance this equation. So let's see how we balance this one. Not that hard, is it? So in this case, we have 2 here. We have a 3 here. And since it's endothermic, we have plus 92 on this side of the equation. So this is decomposed. And now we can do a dimensional analysis here as well. We could take 5.2 grams here. Okay. And we would of grams of ammonia. And it's times 1 over 17.00 gram per every grams of ammonia per every mole. And then we do a times bar here, and we'll have the moles to kilojoules. And we look at the balance equation, and this is a 2, and this is a 92. And this number comes out to 20 when it's all rounded off. It should be 2 sig figs, so we just put a bar over there. Okay, when we do this, so 20 for 2 sig figs in terms of the kilojoules is a positive value. Therefore, it's endothermic. Its energy is absorbed. It's an uphill process for us. Uphill meaning that the reactants are lower than the products. The products go uphill and stay there. All right, the second one here, how much heat does it take to form 6.40 grams of nitrogen? So let's form those 6.40, 3 sig fig grams of N2. This was going to be grams N2 for every mole of N2, and you know the process by now, don't you? Yep. And so this is going to be a here going to be 28. Okay, 28. Then we're going to go times bar Here would be mole to kilojoule here. So we'll do a mole to kilojoule here. We have a 2 here, mole here, and we have 92 here. And so in this particular case, we get approximately 10 of these. Again, here should be 3 sig figs, so it's really 10.0. We're just going to call it that. Close enough for what we're doing. So just check your calculator, whatever your calculator punched out. That's going to be the right answer. Make sure you write it to 3 sig figs. All right. So there you have it. That's how we work thermodynamic calculations involving balanced equations. And don't forget, this is also endothermic, which you knew energy is absorbed.